Okay, so this is problem number 7 for chapter 4.3. So, basically, the problem is given, actually, the problem is f of x equals x cubed minus 12x plus 1. So, here's what they give you. And basically, there are three parts of the question, A, B, and C. So, A is find the intervals on which f is increasing or decreasing. So, you find the intervals on which f of x is increasing or decreasing by taking the derivative and then finding the zeros and then using the number line. So, if you take the derivative, power rule, and then you take a 3, well, you use the power rule up here, and you take the derivative of these, and then you take a 3 out, because that's like a common factor, so you get x squared minus 4, and then it's kind of faint, but you can factor that, so you end up getting 3 times x plus 2x minus 2, these are the zeros, so the zeros for these are 0, negative 2, and 2, so, you know, right here, if you put these on a number line, that any number less than negative 2, if you plug it back into this equation, it ends up being positive. Any number between negative 2 and 0 ends up being negative. Any number between 0 and 2 ends up being negative. Any number greater than 2 is positive. So therefore, you can find the intervals on which f is increasing or decreasing. So if f of x is greater than 0, therefore f if f prime of x is greater than 0, therefore f of x is increasing at negative infinity equals negative 2. I mean, negative infinity, negative 2, and then 2 to infinity. And then it's if the derivative is decreasing, if the derivative of this is negative, then f of x is decreasing. So the interval in which it's decreasing is negative 2, 2. So from here to here. And these points are local maxes and mins. So our local max, you take this x coordinate, you plug it back in up here. So the local max is negative 217, and the local min is 2, negative 15. So once again, you just plug these x coordinates back into the original f of x equation. And find the intervals of concavity. Basically, find the intervals of concavity and the inflection points. So you do that by taking the double derivative. So you just take the derivative of the derivative. So the derivative of f of x is 3x squared minus 12, what we have up here. So you take the derivative of that and you get 6x. So you set that equal to 0. So any value less than 0 comes out negative, and any value greater than 0 comes out positive. So this function is concave upward between the intervals of like 0 and infinity, and it's concave downward between negative infinity and 0. And the inflection point is 0, 1. You just find that by plugging it in. The inflection point is right here, so this point you plug in 0 to find the y coordinate. And that's how you solve chapter 4.3 problem number 7.